Good day everyone. Today we'll tackle or discuss about time rates, conical discharge. We all know that the formula of volume of cone is V equals 1/3 pi r squared times h. In this topic, we will find the equation to differential equation of conical discharge. Okay, let me give you an example. Water drains from an inverted conical tank with a height of 10 meters and a base radius of 5 meters. The water level decreases as the tank discharges. The rate of change of the volume of water is proportional to the square root of the height of the water. Thus, dV over dt is equals to negative k times square root of t, where k is greater than 0 is a constant. Find the height of the water as a function of time. So here's the illustration or the figure in our problem. In the problem, it states that the radius or the height of the conical tank is 10 meters and the radius is 5 meters. So we have to relate the volume to the height of the cone. So the volume of a cone is given by V equals 1/3 pi r squared times height. Since the cone is inverted, the radius and height are proportional. So we have r over h is equals to 5 over 10, or r is equals to h over 2. So in here, the r equals to h over 2 is we have to substitute it into the volume formula. So we have V is equals to 1/3 pi times quantity of h over 2, quantity of 2 times h. So we have 1 over 12 pi times h cubed. So that is our new formula for the volume of cone. So the formula we get is we have to differentiate V 1 over equals 1 over 12 pi h to the third power with respect to t. So we have dV over dt equals 1 over 12 pi times 3h squared dh over dt. So we have to simplify that. So we have pi over 4h squared dh over dt. So that was now our equation. And then the problem states that dV over dt is equals to negative k times square root of h. So we have to equate the two expressions. So we have pi over 4 times h squared dh over dt equals to negative k times square root of h. So we simplify, so we have h squared dh over dt is equals to negative 4k over pi times square root of h. Then we have to divide both sides by h cubed over 3 since h is greater than 0. So we have h cubed over 2 times dh over dt is equals to 4k over pi. So next, we have to rearrange the equation. So we have 1 over h raised to the power of 3 halves dh is equals to negative 4k over pi dt. So next is we have to integrate the left side with respect to h and the right side with respect to t. So we have the integration of 1 over h raised to the power of 3 halves dh, and the integration of negative 4k over pi dt. So we got negative 2 over square root of h plus c is equals to negative 4 square over pi p plus c. And then lastly, we have to solve for ht. So we have 2 over square root of h is equals to 4k over pi times t minus c. And then we have to take the reciprocals of each. So we have square root of h is equals to pi over 4k times 1 over t minus c pi over 4k. Then we have to square both sides, so to eliminate the square root in the variable h. So we have ht is equals to pi over 4k quantity of 2 times 1 over t minus c pi over 4k quantity of 2. So that is our equation to find the height in terms of t. Thank you.
An example of a cone is an inverted conical container has a diameter of 6 inches and a depth of 15 inches. If water is flowing out of the vertex of the container at a rate of 2 pi cubic inches per second, how fast is the depth of the water dropping when the height of the water is 10 inches? So the first thing we have to do is to draw a cone, then label it with its diameter and height. The fact that it is cubic, so it is volume, and that's gonna be dv over dt is equals to negative 2 pi cubic inches per second. So it is negative because over time the quantity becoming less and less. Find dh over dt when h is equals to 10 inches. The problem is the volume is changing over time and the radius is changing over time. So let's say that 3 over 15, and the 3 is the radius and 15 is height. So 3 over 15 is equals to r over h, and we simplify that and it becomes 1 is equal 1 over 5 is equals to r over h. So h is equals to 5r, then r is equals to 1 over 5h. And let's put the formula of the volume. The formula of the volume is v is equals to 1/3 pi r squared h. Then let's plug in the radius into the formula of the volume. So v is equals to 1 over 3 pi times 1 over 5h squared h. So it became v is equals to 1 over 3 pi times 1 over 25 h cubed. Then the answer is V is equals to 1 over 75 pi times h cubed. Then the next step is let's take the derivatives with respect to dv over dt is equals to 3 times 1 over 75 pi h squared dh over dt. Then it became dv over dt is equals to 1 over 25 pi h squared dh over dt. So the dv over dh is given and the height is given. Let's plug that in. So negative 2 pi is equals to 1 over 25 pi times 10 squared dh over dt. So let's combine that together and it became negative 2 pi is equals to 100 pi over 25 dh over dt. So let's cancel out the pi and it became negative 2 is equals to 4 dh over dt. So the answer is dh over dt is equals to negative 1/2 and its unit is inches per second, and that is the answer of this problem.